All right. So we've been talking about systems of equations, and the first thing we talked about was graphing to show that those points where they intersect is where the solutions are, right? The points where the lines, the graphs of those lines intersect are common solutions. It's where they share a solution. And then we went into substitution, right, where we solved for one variable and then plugged it into that variable in the other equation. Then we did elimination, which I think is the most useful piece that we go over, and we'll be using it today. Then we did applications, which are word problems. Stop changing size. Right? We did a couple of word problems. I think in Delta Math they were called context, but they're just word problems. And I showed you how to pull the math out of the word problem. And then we did, well, we haven't done anything else yet. But today we're doing 3 variable systems. And then the next time I see you, we will be doing, well, maybe not the next time I see you, but maybe not till next week. We will be doing systems of inequalities. This is a hard qualities. This is a hard section in Algebra 2. I understand if you struggle with this. It makes sense. It's difficult. It's a lot of steps. So don't feel bad if this is hard for you. It's hard stuff. You probably did a little of it in Algebra 1, but we're getting into it way more in depth. We're adding a little more to it. So a little example, a review example, a recap, so to speak. We'll do a little 2-variable system, right? So I'm going to take 5x minus 6y equals 3. And I'm going to take 7y equals 2x plus 8. The first thing that we need is to have our x, y's on one side of the equal sign and our constant on the other. We need to make sure that they're set up so that our x's line up with our x's and our y's line up with our y's and our constants line up with our constants. And if we look at this top equation, that's an ugly little thing. I was trying to draw that one of those pointy things and it just didn't work out for me. This one I've got x, y equals a constant. So this one's in good order. I'm just going to rewrite it. 5x minus 6y equals 3. When I look at this one, not in order, right? The only thing we want on this side of the equal sign is the 8. So I'm just going to go ahead and subtract 2x from both sides. So I get negative 2x plus 7y equals 8. And that's the proper order that I would want that in. So I can rewrite that under here. And we're going to use the elimination method to solve this. One reason we want the elimination method is there are no x or y values that don't have a lead coefficient, right? We've got a 5 here, we've got a -2 here, -6 here, -7. It's not really easy to just solve the equation for y and plug it in. You'd wind up with crazy fractions, and it's going to give you a lot more work if you tried to use substitution on this. So we're going to stick with elimination. And when we're doing elimination, what we do is the first thing we do is we go, man, this thing is super sensitive today, my pen. Like I'm not anywhere near the tablet and it's leaving marks. So we're going to look at our x values and we're going to go, well, can I multiply 2 times anything to equal 5? And the answer is no. And can I multiply 6 times anything to equal 7? And the answer is no. So I'm going to have to try and find the least common multiple of one of them. I'm going to choose 5 and 2 because they're the smaller numbers. And I'm going to look at those and I'm going to go, what's the least common multiple? And the way you find the least common multiple is you take the bigger number and you go, well, 5 doesn't work, so let's 5 times 2. 5 times 2 is 10, and 10 is definitely divisible by 2. So I'm going to create this to be a 10 by multiplying it times 2, but I have to multiply that entire equation times 2. And now my least common multiple we've decided is 10. So we're going to go, we want an opposite so that when they add together, they disappear, right? So we want it to equal negative 10. So I'm going to go, what can I multiply negative 2 by to equal negative 10? Anyone got an answer for that? What would I multiply negative 2 by to equal negative 10? Yeah. 2 times 5 is 10. 5 times negative 2 is negative 10. And so we're just going to go ahead and rewrite these problems with their distribution. So I'm going to go 2 times 5x is 10x. Then I'm going to go 2 times negative 6y is negative 12y. And then I'm going to go 2 times 3 is 6. And I'm going to do the same thing with the 5 here. I'm going to go 5 times negative 2 is negative 10x. 5 times 7y is plus 35y. And 5 times 8 is 40. And the whole idea of this is that now I can add these two equations together and I don't have a value for x. So I can go ahead and solve it for y. So let's look at this. 10x minus 10x is just 0. It's our whole reason for being here. Minus 12 plus 35y is 23y. And 6 plus 40 is just 46. So now I can easily solve this for y because the only thing that's being done to y now is that we have a 23 multiplied to it. So we can easily just divide both sides. It just wants to keep changing size. I can keep dividing. I can divide both sides by 23. And then I get a value for y. We get y equals 2. And the excellent thing about knowing that y equals 2 is I can plug it into either of our original two problems and figure out what x equals. So I can let's take the top one right here. We've got 5x minus 6y. Well, we know that y equals 2. So I could just plug it in where the y was, equals 3. And we can go ahead and solve this and figure out what our x value is. So I've got 5x minus 12 equals 3. And then we just start undoing everything that's being done to x. And we'll start by adding 12 to both sides, which gives us 5x equals 15. And then we've got 5 multiplied to it. So we're going to divide by 5, and we'll get x equals 3. So this is our solution set for this problem. This is where they share a common solution at x equals 3 and y equals 2. And we can box those up like that. I don't know how Delta Math wants you to put in those problems. They could want you to do it as a coordinate point, in which case you would go our x value first and then our y value, right? But that's how we do the two variable equation. And that was already labor extensive, right? And now we're going to talk about how to do a 3 variable solution. This is time consuming. There are a lot of steps. Watch this over and over if you have to while you're doing your homework. In accordance to the fact that these are so time consuming, I think I only assigned you 3 or 4 problems. I didn't want to give you like 10, 12 problems because I know how labor intensive these problems can be. So I tried not to bombard you with them, but I wanted to give you enough of them that you could at least practice. And if you want, when we come in on Thursday, we can go over one via Delta Math so that we can take a look at them. But right now, I need to move into solving systems with 3 variables because that's what today's lesson is. I do not know why all of a sudden my screen is so freaking touch sensitive, but it is what it is, and I don't have time to figure it out. So we're doing 3 variable systems. Remember this piece of information I'm about to give you because it feels bad. What feels bad? The math? It'll be okay. I promise. It'll be okay. At least it's just 1 unit. Remember, this next piece of information I'm going to give you, I'm going to ask you probably at some point later in our conversation. So if I have 2x minus 6y plus 9z equals, I've done this problem so many times now, equals -8. And then we've got 5x plus y plus 2z. I always put a line in my z so you can tell the difference between my z and my 2 because they're very similar. And then we've got 3x plus y minus 8z equals -28. Notice we have 3 variables, so we have 3 equations. That's an important piece of information you're going to want to know for later. Our starting point comes with breaking this down. We're going to change them. We're going to take 2 of the equations, right? Let's call these A. I'm going to do A over here. I'm going to write 2x minus 6y plus 9z equals -8. And then over here, I'm going to have 5x plus y plus 2z equals 10. And then we're going to take one of the equations we just used, doesn't matter which one, and couple it with the equation we didn't use. And we'll call that our B set, right? So I'm going to do it 2x minus 6y. I could have used either equation. It's okay. Plus 9z. I just grabbed the first one because I've done it with the first one so many times that I already have the math written down. And then we're going to write 3x, our bottom one, plus y minus 8z equals -28. And the idea is we're going to look for a variable that's easy to eliminate. I, in this sense, am going to choose y. And the reason I'm going to choose y is because it doesn't have a coefficient, right? I can't multiply 2 times anything to get 5. I can't multiply 2 times anything to get 9. But I can multiply y times 6, right, to get 6y. So I'm going to do that. I'm going to go ahead and eliminate my y variable. Okay, well, it's being recorded, Rhea, so you won't miss anything too extensive. So here we go, okay? I'm just going to rewrite this top problem like I did before with the 2 variable equations. And then I'm going to distribute this. So 6 times 5x gives me 30x. 6 times y gives me plus 6y. It's our whole reason for choosing 6 in the first place. 6 times 2 gives me plus 12z. And then 6 times 10 just gives me 60. And so now I can add these 2 equations together, and my y is going to disappear. Okay, so x plus 2x plus 30x gives me 32x. Minus 6y plus 6y equals 0. It's the reason we did it, right? It gets rid of one of our variables. 9z plus 12z gives me plus 21z. And then minus 8 plus 6z gives me 52. Now we're going to come over here and we're going to do the same thing, right? We're going to go, well, I can't multiply 2 times anything to get 3. I can multiply y times 6 to get negative 6. So why don't we do that again with this side? Let's multiply this times 6. It won't always be the same number, just so happen to be in this one. The one I do in the ed puzzle will work a little differently. So I'm going to rewrite the top equation just like I did before. And then I'm going to distribute the bottom one. So 6 times 3x gives me 18x. 6 times y gives me plus 6y. It's our reason for being. 6 times negative 8 gives me negative 48z. 6 times negative 28. Hold on, I got to look. I wrote that down. I don't remember the answer. 6 times negative 28 gives me negative 168. And so now I can add these two together and our y will drop out. If I chose the y in this set as the variable that I'm getting rid of, I need to choose the same variable to get rid of in this set, right? If I get rid of my y variable here, I need to get rid of my y variable in this one. And you'll see why in a minute, but make sure that whatever variable I eliminate in A has to be the same variable I eliminate in B. 2x plus 18x, 20x. Minus 6y plus 6y, bam, just 0. 9 minus 48, 9z minus 48z gives me negative 39z. Negative 8 minus 168 gives me negative 176. And if you notice, I am left with a 2-variable problem here and a 2-variable problem here. And we're going to use those to make a 2-variable system and figure out what our x and z equal. And then once we find that, we can plug it back into one of the original equations and figure out what our y is. That's as high as it goes. That just says 3 variables. You're welcome. Can I scooch it up now? Okay. I'll leave these two showing. So we're going to take, let's go green. We're going to take this equation. We're just going to write it here. 32x, I don't know why it's writing so sloppily, plus 21z equals 52. And then we're going to take this one and write it underneath. And we're going to have 20x minus 39z equals negative 176. And we are going to figure out what x and z are. Now, the math on this is complex. I just grabbed a random question, turned out to be fairly complex numerically, but we can do this. We are going to look at these and I'm going to go, okay, well, I can't multiply 20 times anything to get 32. And I can't multiply 21 times anything to get 39. So I'm going to have to find a least common multiple. And these are even numbers. So I'm going to do those. Plus, I've already done the math on them. But when you want to find that least common multiple, you're going to take the bigger number of the two. In this case it's 32. You go, okay, well, 20 doesn't go into 32. Well, let's look at 32 times 2. That's 64. 20 doesn't go into 64. Do it times 3. That's 96. 20 doesn't go into 96. I already know that 5 is 160 and 20 does go in to 160. So I'm going to multiply this one times 5. I'm going to change the color so you can see that it's something different that I'm doing to the original equation that was there. And then this one, this one's going to give me 160. This one I want to give me the opposite of 160. So I want it to be negative 160, which means I have to multiply it times something negative. And 20 goes into 160 8 times. All right. So what's going to happen now is we're going to distribute. 5 times 32, well, we know by design that that equals 160x. Then we're going to go 5 times 21. That is going to equal plus 105z. 52 times 5 equals 260. And then we're going to do the same thing for the bottom one. We're going to distribute that negative 8 through. We know by design that negative 8 times 20x equals negative 160x. It's by design because we want the x to drop out. Negative 8 times negative 39z, we know it's going to be positive because a negative times a negative equals a positive. And we're going to get 312z. Then we have to do negative 8 times negative 176. So we know again is going to be positive, and it's going to be 1408. It's an ugly 08, but that's 1408. Let me make that prettier for you. Wow, I wonder why it changed colors on me. I didn't think I hit that thing. And so now when we add these two together, our x value drops out, which is our whole reason for being, right? The whole reason we did this is so that we could be left with only one variable, and that variable is going to be z. So we're going to have 417z equals 260 plus 1,408 is going to give me 1,668. I still have 417 multiplied to z, and we want to know what 1z is, so we are going to divide by 417 and divide by 417, and that is going to give us z equals 4. So what do you suppose I do with that z equals 4? Any guesses? Anyone want to take a shot? We know what z equals. We still need to know what x and y equal. No guesses? You're right, I plug it in. I plug it into one of the equations. Now, I don't plug it into one of the original equations because we don't have a y value yet, but we do have x and z's in either one of these. So I can choose either one of these and it'll give me an x value. So I'm going to choose, ooh, that one went way small. I'm making myself dizzy. I'm going to choose the 32x plus 21z problem because it looks like the math is easier. So 32x plus 21z. Well, z is just 4. So where that z goes, I'm going to put in a 4. Equals 52. I don't know where that clock came from either. I don't even know how to make one on there. 32x plus 84, right? 21 times 4 is 84. Equals 52. And now we just undo everything that's being done to x. So I'm going to start by subtracting the 84. and I will conveniently get 32x equals negative 32. And now we have this 32 that's being multiplied to x, so I'm going to go ahead and divide by 32 and divide by 32. I wanted to make it x, and I get x equals negative 1. And so now I know what my, I didn't put in the negative. Now I know what my x is, and now I know what my y is. I mean, what my z is, right? So if I was writing it in terms of a point, I would know it's negative 1. We don't know what y is yet, but we know that z is 4, right? So all we have to do is take one of our original equations. I'm going to go with 2x minus 6y plus 9z equals negative 8 because I can see it right there. If you see, it was our top problem, our top equation, 2x minus 6y plus 9z equals negative 8. I could have chosen any of the three, right? Instead, I chose the most difficult one because if I had chosen one of the others, the y is already by itself. But it doesn't matter. No matter what equation we choose, it should give us the same answer for y. So 2x, well, we know that x is negative 1. Minus 6y, we don't know what y is yet. Plus 9z, we know that z equals 4. And the whole thing equals negative 8. And so now it's just solving for y. I have negative 2 minus 6y plus 36 equals negative 8. And then I can combine my like terms. So I wind up with minus 6y plus 34 equals negative 8. And then I just undo what's being done to y, starting with what's being added to it. So I'm going to subtract 34, subtract 34, and I wind up with minus 6y equals negative 42. And the only thing we have left is this negative 6 being multiplied to it. So I'm going to divide by negative 6 and divide by negative 6. And I get y equals 7. And we can write that up here as our x, y, z solution.